There we go. All right. We ready? We going live? All right. Since we're going live, I will start off with the introduction. I'm glad to see that we've got a pretty good turnout again this month. The mic is not working? Yes, it's working. Yes. Continuing the tradition of excellence on these talks, we have brought over Dr. Gareth Wynn-Williams from the University of Hawaii Institute for Astronomy in Manoa. Dr. Wynn-Williams went to high school at University College in Hampstead, all right? And please feel free to correct my pronunciation. It's the American's job to mispronounce all English words, isn't it? All right, and from there, he spent a summer working at the University Physics Lab in Teddington, went from there to Trinity College in Cambridge. After graduating from Cambridge, he went to the University of Nairobi, taught for a year out there, returned to Cambridge for his graduate work, which was on 6 and 21 centimeter observations of dense H2 regions. Is that pretty close? All right, and he went to Caltech for 3 years, back to Cambridge, where he was basically an assistant professor, and then we brought him out to Hawaii, where he's continued his studies of galaxies in the infrared, dense in star-forming regions. And he's also currently the president of the Hawaii Academy of Sciences, which is the group that does the science fairs. He'll be talking about the Antikythera mechanism, and so if we could give him a warm Maui welcome, I'll present to you Dr. Wynn-Williams.
Well, I got on the plane this morning expecting to fly to one island, and I seem to have landed on two, since we have this the Second Life set up here, which that shouldn't affect much what's going on here, but you're really supposed to be watching me, not that. That's the second choice if I get a bit too dull. So the way that I pronounce it, and the way that most people I've heard pronounce it, is the Antikythera mechanism. But the number of people who don't speak Greek and use that word seems to exceed the number of people who do speak Greek and use that word. So I don't really know how it's pronounced. So let's talk about what it is rather than how you pronounce it. This is a picture of the Antikythera mechanism. This is what I'm going to be talking about. This is part of it. What it actually is an encrusted lump of bronze that is in the National Archaeological Museum in Athens. And this is a random tourist looking at it to give you an idea of the shape. And here are several of the larger pieces. There are some smaller pieces as well. And these pieces are what all the fuss is about. Here is a kind of catalogue of all the various bits. So first of all, why is it called the Antikythera? Well, Antikythera is a Greek island. Here is Greece. The Peloponnese here's Crete. That thing is up here. Kythera is a big island. Antikythera is a small island. In fact, if you want to see what it actually looks like, here's Google Earth, or rather Google Aegean. This is the island. It's about 6 miles long. It has a year-round population of about 45 people. It has one doctor, according to the guidebook, has one doctor, one policeman, one restaurant and 2 bars. I think the restaurant and bars cater for the summer population that come in. It's a lot of tourists come in the summer. And what we're dealing with is that more than 2,000 years ago, there was a shipwreck right along here. In that, what we're talking about, the Antikythera mechanism, is this piece of bronze that was discovered in that wreck. So let's talk a bit more. Let's go back to PowerPoint here. This is a picture of Antikythera, now a typically very dry Greek island. So let's talk about the discovery. The discovery was made in about 1900, just over 100 years ago, by sponge divers. And sponge diving is a common pursuit in this part of the Aegean. And the wreck they found had not been touched for 2,000 years. And the reason is interesting. The reason is that around 1900 is when the technology of diving took a leap forward, and you started getting these diving suits. Remember the pictures of these big bronze helmets and leather things, and you pumped air down to these divers. These sponge divers had invested in some of this stuff, and this allowed them to get down to depths which no one had got to before. And this is very important, because this is why this thing survived for 2,000 years, and things were not ruined from it. This was in fact the first major marine archaeology activity that goes on record. The first time that archaeologists really had worked underwater. And there was 2 years of salvaging by the Greek Navy. And the mechanism itself was found in 1902, though it wasn't recognized as being that important for a while. And everything, I should say the mechanism was originally assumed to be an astrolabe. Don't worry about that for right now. Everything that came out of this wreck was taken to the National Archaeological Museum in Athens. So there's a very good record of all the stuff that came away. Well, talking about the archaeology here of the wreck, we can do carbon dating on the planks of wood forming the hull of this ship that had sunk. And the planks give a date of about this, 220 plus or minus 43. Now that's how old the wood was. The ship, of course, would be made later, after the tree had been cut down. The ship must have existed before the shipwreck. So we know that the wreck must have happened sometime after that. Now, in the wreck, there were coins, there were utensils, there were amphorae. Those are big kind of vases. And they dated pretty unambiguously to between 50 and 80 BC. And I've not come across any controversy about the age of the wreck, or about there's no controversy about the provenance of this mechanism. It dates from a shipwreck something like 60 years before the birth of Christ. So the best guess is about 65 BC. But the actual items could be older, of course. All right, now, the shipwreck turned out a lot of very valuable artwork, and in particular these bronze statues. Now, bronze Greek statues are extremely rare, and the reason is that bronze is valuable. And let's put a kind word to it. Recycling was often took place, and so these things. I think it's true to say that about 90% of all the Greek bronzes that we know of have come from shipwrecks, because any Greek bronzes on land would have been melted down and turned into something else. So this wreck itself turned up some beautiful artwork, also some stonework. The stonework is not in particularly good condition. And just to show you what I mean by that is the bronze work is featured in enormous halls inside this museum. The stonework, which is much more corroded, is just in the lanai cafeteria area. So you can sit next to this. So this is obviously not such a great thing. All right, so let me just, actually, before I do that, let's show a little bit more close-ups of the, here. This is just a little bit of movie that a friend of mine took in the museum, just to give you some better, this is what we're talking about, okay? I'll be showing you more pictures later, but just notice there are the gear wheels and things, little details. Yeah, look at these gear wheels here. All right, we're getting more pictures, but here again, these are the sort of scales. Look at this kind of radial pattern here, and there are scales, and there's all over this thing there is writing. And the writing is all Greek, pretty much conventional Greek. If you can make out the letters, the scholars can read it. And pretty soon when people started to examine these pieces, this is way back, even back in the early part of the 20th century, they would pick out words here out of the Greek. So you'd find a fragment. And they quickly noticed there are a lot of astronomy words here. Sun, Venus, rising, 12th part of a circle, spiral divided into 235 sectors. That's a particularly interesting one there. These were all just read off the surface of part of these fragments. The next thing is that other surface features here. There are curved scales, you see? These are gradations. This whole thing is about maybe 3 or 4 inches across. And you've got scales. And here's a kind of people are trying to put some of these scales together. We'll see more about that, those pointer patterns in a minute. And then we have these gear wheels, and those gear wheels are actually better in that movie I just showed you. But you can see some there. There's a whole bunch of these. Okay, now there was a major paper written. This thing was sort of stayed in the background for a while. They say that most of the archaeologists were more interested in the sculpture and the things related to the kind of cultural activities that they were dealing with. The things were noted, and it was thought that maybe this was some kind of astrolabe, which is a kind of thing for measuring angles in the sky that we knew existed at that time, or they knew. But then in the 1960s, after many years' work, this man here, Derek de Solla Price, who was English-born, but was a professor at Yale University for most of his career, wrote a major paper in 1974. And one of the major things he did, he used gamma rays. And he got an image. This is one of his images. He got permission to fire gamma rays through some of these pieces of encrusted bronze. And he could see there was many more details. He could see these gears in here. And you see some sharp edges, more gears up here. And he tried to work out from these gears what the thing might do. In other words, he studied the math of the gearing, and he showed that it was an astronomical calendar modeling the motions of the sun and moon at least. And I'll be showing you the kind of math, the math behind that in a few minutes. So this work actually didn't. What's a little bit strange is this didn't really make as much impression as it should have done. And I think he was unfortunate in one way, and that is that one particular person read his paper, and that was Eric von Daniken. Remember that name? Yeah. Chariots of the Gods. And von Daniken sort of used this as proof that intelligent beings had somehow come to Earth and delivered calculating machines to the Greeks. Price, of course, had nothing to say about this. But the trouble is, there was a certain guilt by association. So people hearing about the Antikythera mechanism, oh, that was in that Van Daniken monstrosity, and they sort of tended to ignore it. So it was some bad luck, I think, on Price that he was inadvertently came into bad company. All right, let's just say a little bit about why Price could deduce that this machine was connected with the moon and the sun. And we're talking here about gear wheels. He isolated a particular group of gear wheels here in the mechanism and noted which ones touched which. And I don't really need to go through this, but what we have here are 3 axles. And at this axle here, we have a 32-tooth gear and a 64-tooth gear fastened together. Here we have a 38-tooth gear and a 48-tooth gear fastened together. And then here we have a small gear with 27 teeth and a big gear with 27 teeth. So this is 127. They're on the same axis. So what you can see is if you turn one of these gears, they go around this way, that'll go around that way, this will go around that way, that'll go around that way, it'll turn the big one. Okay? So, and if any of you have ever played with Lego or constructor sets know how to calculate ear speeds. You just basically put the ratios of the teeth together. So let's just do that. This is what de Solla did. So here he's got his three sets of gears, a 64 tooth going to a 38, a 48 going to a 24, 127 going to a 32, and you multiply these together to get the overall ratio. It's a standard auto mechanics. That's all we're talking about here. You get a ratio of 254 over 19, which is 13.36842. All right? Is that an interesting number? Well, let's see. Turns out that the number of sidereal months in a year is 13.36827. Right? That this ratio comes out to 1 part in 100,000. Okay? This thing can reproduce a ratio of motions in the sky to 1 part in 100,000. That clearly means that we're probably not talking about coincidences here, but we really do have something that's trying to model the sun. Okay, so that was the work done in the 1970s by Price. He sort of set the thing pioneered the thing. Some of his conclusions now are not accepted, and that's largely because we have much better data nowadays. And I want to show you, I should say that the recent work is really divided into two camps that have been rather different. First, there was this man called Michael Wright, who he'll feature in a video I'm going to show you in a minute. And he managed to work with another scientist and got some much better X-rays. And he built a working model, which I will show you movies of in a minute. But this interesting. This man was his goal. He's not an academic. He doesn't write scientific papers. He's not attached to university. He was employed by the London Science Museum. I think he's now retired. And his goal was to reproduce the machine. But starting about 6 or 8 years ago, there was a new collaboration between the United Kingdom and Greek academics. The United Kingdom was sort of focused more or less at the University of Cardiff. And they, the thing that really got them going was that they introduced two new kinds of technology to study these fragments. And these new kinds of technology had a big impact. So let's talk about what they did. The first technique they used was, I got these in the wrong order. Okay, I missed out a slide here. I guess I have to explain what it is. The first thing I wanted to talk about is something called, let me just get where I am here. This is a thing called interactive relighting. And it's a technique introduced by someone at Hewlett-Packard, and the only way I can demonstrate it to you is actually on the Hewlett-Packard website. The idea behind this is to get much better pictures of all the surfaces, all the exposed surfaces they can. And the way this was done, the main thing is the computation that's involved. What the guy did, here we'd have our piece to be studied, and he would set up a camera pointing at it, and then all around at many, many different angles there would be lights shining. And he would take a sequence of pictures with each light shining from a different direction. Then he'd rotate this a little bit, and he'd do it all again. Then he'd do that again. So you have vast numbers of pictures of this fragment all lit in different directions. Then you put the whole thing in a big computer program, which is what this thing is really all about. And it's a bit like CAT scanning in a way. Well, let me show you what you get. This requires a little piece of Java here. Okay. Now there's the picture. Now what I'm doing, I'm going to press the button on my mouse and move my mouse over it. Can you all see that? And you get the effect of shining the lights from different directions. Okay? Isn't that beautiful? And that's all synthetic, if you like. He's used a computer program to take mixtures of the pictures taken with the lights at different angles. And this has allowed people to find all sorts of new prescriptions, new writings on the surface. And And again, this means the scholars can study this stuff without having to go to Athens. And the Greeks have said that these things will not leave the museum. All right, that's one technique that was very successful. Technique is probably one that's more important is this thing called X-ray tomography, and this is quite similar to the kind of the medical techniques that you get when you're given a three-dimensional picture of part of your body, except that the X-rays you use if you want to study something made of bronze are much higher energy, much shorter wavelength than the wavelengths you use to study broken wrists. The machine that was used to get these pictures would certainly kill you. And if you fell on here is being delivered. It came out from Britain, a company in Britain. Here it's being delivered to the museum in Athens, and then all these pieces were then subjected to these X-ray scans. I'm going to show you some of the results because they are extremely beautiful. So first I want to show you a still photograph that is here. So here's a still photograph of X-ray shining through the biggest chunk in one direction. Now what I can do here, this is when it gets remarkable, I can start zooming in on it. Go up to here. All right, just look at this. These are the gears inside that mechanism. 65 years before the birth of Christ. Just remember that. And so this is a still picture. Now the other thing you can do, as I say, with this tomography, you can get a whole series of pictures, a whole series of scans taken in different directions, put them in the computer, and then try to reproduce a three-dimensional image. So what you're going to see now are a couple of movies that show you the three-dimensional structure. So let's do this one first. So you're just kind of scanning through now. This is just a way of displaying the data. You're moving down through this piece of bronze. Okay? Picking up different gear wheels at different levels. There's still more gears appearing now. Look at those. All right, that's one way of showing it. Then let me show you another way that's been used. Here. The colors are meaningless. Notice the thing is compressed. That's probably because it got crushed in the wreck. But nevertheless, you see these different layers. You can see it can help solve which gears touch which ones. Look at that. Isn't it amazing? Okay, so these are the new data that were produced just a few years ago, and they led to major rethinking of some of this. Let me see, I'm going to down all these detailed innovation. Sorry, let me do the next one. Yes, what I want to introduce now is, having showed you all those gears, I need to make a big kind of, I'm not going to explain all those different gears too, that's much too complicated. I'm going to introduce this guy, Michael Wright. Michael Wright is the guy I said who worked in the Science Museum in London, and he built a model, a reconstruction of how he thought this thing worked. And this thing, you see it in the video, it's about this size. And what I should say first, I should say one thing is that approximately half the gears in his reconstruction correspond to what has actually been found in the wreckage. About half of it is conjecture based on various kind of assumptions about what it seems to be missing. We know that part of the mechanism is missing, there's no doubt about that. So people have had to conjecture what it is. And a lot of the front side is in fact conjecture. Nevertheless, let's hear what Mr. Wright has to say about it. And I do apologize for the excessive number of British accents here. Oh, I forgot to set up a microphone. Let's just, hopefully you can hear this.
Michael Wright, a museum curator from London, spent decades studying it in order to work out what the device was for.
Dials, one at the front and one at the back, which we'll look at in a moment. And it's all driven by working from the hand nod here. On the front dial, we've got two scales. The inner ring is the zodiac divided into degrees. The outer ring is an annual calendar scale, 365 days.
The device is a machine for predicting the motions of the heavens. When you turn the handle on the side, pointers move around the front dial, showing the movements of the sun, moon, and the 5 planets that the Greeks knew. The fastest pointer here is for the moon, going around the sky once a month, while the white and black ball shows its changing phase. Inside, a sophisticated setup of wheels riding around on other wheels models the varying motions of the planets, according to the Greeks' astronomical theories. As the side handle turns, the planet pointers sometimes move forwards and sometimes backwards. Meanwhile, the sun and moon pointers vary in speed, just as the actual sun and moon do, seen from Earth.
Now we'll look at the back. We've got two displays together here. The upper one is basically a calendar. The spiral scale is divided into months, each of which is named, and this is a cycle of months, 235 months, which fit into 19 years. These are months measured by the moon.
An extendable pointer with a little needle on the end tracks the spiral groove, just like the stylus on a record player. When it gets to the end, you can lift the pointer up to reset it. One of the little dials just inside the spiral shows the dates of the ancient Greek games, including the Olympics, on a 4-year cycle, while the other tracks a much longer 76-year cycle.
The lower display is giving the times at which there may be eclipses. Again, it's graduated into months, and the markings are just in those months in which we expect there to be an eclipse either of the moon or of the sun or of both. The thing about eclipses is that they happen according to a pattern which repeats after 223 months. So here we have a 4-turn spiral scale with 223-month divisions.
This dial is one of the most exciting parts of the mechanism. It was used to predict eclipses of the sun and moon according to a repeating 18-year cycle. The Greeks probably got the data from ancient Babylonian astronomer priests who had been observing eclipses for centuries. Inside the mechanism, you can see the gear trains that drive the pointers on the back dial. This shot also reveals that this model was made of recycled metal plates, just like the original would have been. This is the first model of the Antikythera mechanism to incorporate all of its known features. Thanks to Michael Wright, it's working again for the first time in 2,000 years.
Okay, got people in the back here, enough of that. Okay. Well, I'm not going to... The point is that... let's see, I'll just try to summarize a few of the points he makes. I'm sorry, I forgot about the microphone. I need audio. Otherwise, I would have set that up. Let's look at some of the points he makes here. Let's say this guy, Michael Wright, has rebuilt this, has built this model. Here's the size of the model. This is the same size as the actual device itself, or the remnants of the device. What happens is you turn a handle at the side here, and that moves the dials around. There's only one handle, and then everything moves forward in the same way that we only have one time scale. We start here, and all the planets and the moons and the sun, etc., follow a pattern. So you have a handle here which you turn by hand, and that runs these things here. And some of the features here, these points, these around here represents different directions in the sky, different directions in the ecliptic or in the zodiac. These each one, there's the one in the sun, one is the moon, and the 5 others are the visible planets that were known to the Greeks. That's Mercury, Venus, Mars, Jupiter, and Saturn. This little ball here turns around, and one side's black and one side's white, and this gives you the phase of the moon. That's probably the main points out of this particular feature. Let me show you another animation here while we're on to movies, which I would describe as one of the most beautiful animations, computer animations I've ever seen of any kind. This was put together by someone who works in the planetarium in Milan, is an Italian, who got hold of, or presumably communicated with Michael Wright, got the details of his model, all the numbers of gear wheels, how it was together, and then just animated that. And this doesn't have any sound, so you can just enjoy this. But let's put that up there. This is just amazing. Here's the moon with its rotating phases. You see what, black and white in that little moon? And here's the handle that you're turning at the side here. Yeah, quite simple, really. Okay, I should say that this is Vincenti is the animator in Milan, and Michael Wright is the guy you saw. There has recently, since that was made, been some criticism that maybe the machine wasn't quite as complicated as that. Certainly, it seems to be agreed that there were dials that point to the angles of the planets. But it may be that this other mechanism has 5 little dials in the kind of arranged around the big one, each one of them for a planet. So you have a little dial for Saturn, dial for Jupiter, dial for Mercury, dial for Venus, dial for Mars. This would not require you to have that very complicated multi-axle construction, which Michael Wright was able to build it. it is possible to. It may be that the actual Greek thing was not quite as complicated as that, because it's that front panel that is missing. Nevertheless, most of that certainly does work. So just to show you the way what he thinks is going on here, you have the two of these pointers. One is the sun, one is the moon. There's no doubt about that. There's no doubt about this little mechanism here that shows the phase of the moon. But the conjecture is that there were other planets, 5 other things here. And the question is whether these 5 other pointers went round the same axle here, or whether there are other little dials up in the corners. That's the dispute at the moment. Now the back dials are also interesting because there's more of these exist, and these provided more of the clues. One keeps track of the calendar months over a 19-year cycle. And that's because, I can't remember the number of, how does this work now? If January the 1st is a full moon, the next time full moon occurs on January the 1st is 19 years later. I think that's right. Can anyone correct that? No, the astrologers here? Okay, this one down here is based on what we call the Saros cycle. This is a cycle known to the Greeks that gives you an idea when there may be eclipses. It doesn't tell you that there will be an eclipse, but the Saros cycle you can read about in astronomy textbooks. It's actually quite tricky stuff, and it gives you a good clue as to whether or not you may see an eclipse sometime during that year. There's also the 4-year Olympic cycle is in there as well. I can't remember just where that is. Now, one other thing I should explain here. All these things I've described about looking at the heavens, we know that the Greeks knew this stuff. This machine does not tell us anything about what the Greeks knew about astronomy. All that has all been written down. People like Hipparchus, other astronomers wrote it down. So what we're doing, we're matching a machine to what we know that the Greeks already knew. But just to remind you, the Greeks, of course, worked on this model of the universe that we now think of as incorrect. They believed in the geocentric universe, where the Earth is the center and the sun and the planets and the moon all go around in their complicated patterns. That, of course, that made life much tougher if they came up with a heliocentric model, the heliocentric idea, which is the one that we think of now with the sun at the center and the other things going around it. That would have been much easier to build. The Greeks made life tough for themselves by sticking with the geocentric model, if you're familiar with that. Here's more details. Hipparchus, who lived about 100 years, a little bit before this, maybe 100 years before that, had noticed that the moon moves faster during some parts of the month than others. Now, some of you may know this, some of you may not. But just if you go out and watch the moon moving from night to night, there's a different number of degrees each night. It doesn't move smoothly. And now we know this is because it's an elliptical orbit. And that all fits in with what we know about elliptical orbits. The moon's orbit is quite elliptical. But nevertheless, Hipparchus didn't know it was an ellipse, but he simulates this with a complicated peg and slot mechanism. So the thing here that many of you probably didn't even know, that the moon moves at different speeds, different times of the month, was built into this model already 2,000 years ago. So, where did it come from? So here we're going back into the archaeology. The amphorae, we're talking about stuff on the same ship now. The amphorae were in the style from Rhodes. And I can show you roughly where Rhodes is. If we go back to here, back to Google Earth. Let's come back. Rhodes is up here somewhere. Although this is now part of Turkey, this is very much part of the Greek Empire, and Rhodes was in this region here, and I can't recognize it. Someone may be able to do that better than me. Anyway, that's where the amphorae tend to come from. As I say, Hipparchus was active in Rhodes at this time, and so it's tempting to think that maybe this thing was built by one of Hipparchus's students, say. or a protege of his, because Hipparchus had a major school of astronomy there. Another thing that's interesting, works of Cicero, the Roman writer. There's a mention, there's a description of a machine very much like this in Cicero, but I think it had always been dismissed as a traveller's tale. Cicero himself never saw it. He described someone having come from Rhodes and seeing this thing that had pointers and dials and things like this, and it had been sort of dismissed as perhaps an exaggeration. I don't know how reliable Cicero is as a writer. But now looking back on it, if you read the words of Cicero, he describes it perfectly. But it's kind of complicated. If you look at some of the actual lettering on here, the months were written in the style of Corinth, which is another part of the Greek Empire. It's not completely certain. I'd say Corinth is interesting because Archimedes worked in the Corinth area. So is there a link with Archimedes? Very brilliant scientist. Oops, I've only really got one more slide here. Go back to here. Oops. Well, my last slide was, I think all it said was, what's it for? Yeah. So it leaves really with two big questions. Is it unique, and what was it for? The question of uniqueness is we don't know anything like it. There are a few examples of ancient geared mechanisms, but anything older than this is maybe 2 or 3 gears. And then after this, there is nothing of anything approaching this complexity until you get to about the 14th century. In other words, 1400 years. And that's about the time when the big cathedral clocks in Europe started getting built, and clock making and mechanisms became very complex and very skilled at about the 14th century. But there's nothing in between. There's a couple of small, there's one or two small devices containing maybe 2 or 3 gears have been known. But otherwise, it's unique. Well, is it unique in itself? Well, probably not, because first is, I mentioned this propensity for recycling. Almost anything, bronze is expensive, difficult to make, difficult to get. So people tended to melt down anything that they didn't use. Anything in your attic, you melt it down, make it into something else. Let's say recycling is the kind word for that. And we saw that with the Greek sculptures having been destroyed as well. Now, looking at, there's an interesting clue here hidden in the construction itself. And if you look at the construction, there don't seem to be any spare holes or any kind of odd little bits of brackets that don't do anything. In other words, it does not look like a prototype. Nobody's going to build that thing first time round from scratch without getting at least one gear in the wrong place. But there are no signs of any errors, which suggests that this is built to a pattern. Of course, we haven't found a serial number yet. That would be great if we could find a serial number. But, so there probably were others like this that were made, and maybe one day we'll find some. So what was it for? Well, the connection with astronomy is indisputable. One possibility is, one thing we can throw out straight away is it's nothing to do with navigation. This thing only describes where the planets are along the celestial line, the line of the zodiac in space. If you're navigating, you want to know about stars all around you. And this thing doesn't talk about, in fact, it doesn't even mention stars except for the sun. So this machine is no use for navigating. How about education? Well, it might be kind of an educational tool, but then you wonder why it was made so small. I mean, its smallness is one of the remarkable things about it, the precision that had to go into making this. And if you're trying to teach astronomy to a class, you'd build something bigger. At least I think you would. Is it connected with astrology? Well, that's possible, but I found in one of the papers I read, there's a reference that it doesn't tie in with the kind of astrology that the Romans were doing, the Greeks were doing at that time. I don't really understand that remark. I might try to follow that up sometime, but there are arguments that it probably was not for astrology, but I don't know how strong those arguments children's toy. And this is, in fact, I just want to show you a little video here, which you may not understand why I'm showing it to you. Here. So just watch this video. I'm afraid it's going to be sound again, but there's not much. It's mainly a thing to watch, not to listen to. And this is where's the start button? I can't see.
That's something he's going to show us. What have you got? Study device. Another device.
Okay, I think I've done enough to prove my point. About 80% of you are smiling. All right. And the point I want to make is that there's human beings, for some reason, many of us, most of us, and particularly the male, particularly men, can take pleasure in machines and are willing to buy a Rolex instead of a Casio watch. Why do people buy a Ferrari instead of a Subaru? Why do you buy a Cuisinart instead of a Kenmore? People love machines that work well. And so I have no trouble in seeing that this kind of craftsmanship that went into this Antikythera machine as being something produced as a thing of beauty. And that beauty is the beauty of working machines. It leads to an interesting question. There's nothing to do with astronomy at all, and that's to do with evolution. And what we now learned is that the Greeks themselves, if you agree with what I said, showed this love for machinery that is very common among people nowadays. The Greeks 2,000 years ago had this love of machinery. How did we get that love of machinery out of evolution? How do we evolve? What is it that processes filtered out that the people who survived to become humans were the ones that loved machines? There weren't many machines around 5,000 years ago. So that's just a little sort of conjecture on my part. Finally, I'll say one little comment. JD mentioned that I grew up in London. I went to school in London. It was one of these very good school, fairly old-fashioned school at that time that tended to sort of divide people up into, or encourage you to divide at an early age between those who wanted to study languages and classics and philosophy and those who wanted to be scientists. I actually had to make that kind of decision when I was about 15 years old. And there's always this little bit slightly British classiness about it, that somehow doing the classics, the Latin and Greek, was the kind of the right thing to do. Geeks. Well, the great moral of my story today is that the Greeks had geeks too, and I feel great about that. Thank you. Hello.
In that QuickTime movie that you had a Michael Wright device,
Yes.
was that available? Was found on?
It's on YouTube. Okay, that is actually on YouTube. And if you go to, we can do it right here. If I do Antikythera. I know, I actually stole it from YouTube. And here it is. There it is. So all you need to do is Antikythera into the search thing of YouTube. And this is this thing here. The Italian one, yes, but to get the high resolution, you've got to go to the Italian site. There's a low-res version on YouTube. In fact, the Italian thing, the full resolution is nearly 2,000 wide. There you are. So this is the YouTube thing. Yes. Hello.
Original battered pieces were found in a shipwreck. More than a...
Yes.
Would the machine have had value in keeping calendars in the state?
I'm not sure, because the thing is that other people have suggested this. In fact, I gave this talk to some of the classicists in Honolulu that they picked on that. I'm not sure the calendar's very much use unless it gets down to days, individual days. And an individual day here is just a gradation of about 1 degree on the dial. Okay, there'll be 365 days here. So to get the day right, you're there. I don't know that you'd really use this device to track days. Yes, it would. But remember, this is the Greeks. They had slaves to do those calculations. The Romans had Greek slaves to do these calculations. It's much cheaper to hire slave mathematicians and to build a machine like this. That's an argument I don't know what the actual market prices are, but that's an argument I've heard against that. Okay, I'll repeat the question. Yes. Yes.
I don't know the state of corrosion. It looks bad, but if the little dials in there aren't current enough, and if it was crushed, that would tell you the date it stopped if it was current. So has anybody tried to look through those impressions to try to get a finer date?
Okay, the question. Yeah, I hear that's an interesting idea. I heard the question is, if we assume that this thing was being kept up to date on the ship, by analyzing where the dials, we might be able to get a date for the shipwreck. That's the first time I've heard that suggested, and I don't know if that's been done or not. It's an interesting idea. I think the next was there. Yes.
I'm wondering if the red stage planet was predictable then without using computers. Are they predictable when the planet goes?
Yes. The question is it predictable when a planet will go retrograde without a computer? Yes, and that's what the slaves are for. The calculations that were done, the tables that were produced by Hipparchus and then later on by Ptolemy, who was a few years later than this, were extremely precise, and they were able to calculate. And the Greeks had a kind of theoretical model of epicycles going around, and the centers of the epicycles were displaced. Very sophisticated models, which it was a shame that were wrong. But as I said, this doesn't add anything to the math of the Greek theory. Yes?
Does this maybe add anything to what we know humans are working with happening? Or if you're going to draw on
Yes.
but what tools would it take to do it? You think that we were that advanced?
Well, so the question is, what do we know about the metals that were used here and about the tools that were used to create it? At this time, there was a big tradition of jewelry making. So there is some very precise bronze work. People were able to work with bronze. We had not seen anything like that, like these gear wheels. And remember, some of these gear wheels have very strange numbers of teeth. There's one with 243 teeth. And it has to be 243. It's not an approximation. It has to be that for the model to work. And so they worked out ways of doing that. And we don't know how they did that. Yes.
What is remarkable about it as to the time?
So the question is, what is there remarkable about it? The main thing is that has no precedent. There's no sign of anything simpler. It did not appear to have evolved out of anything. It looks like we don't have any tradition of building machinery, any tradition of using gears. And then after it, nothing after it. Now, clearly, a lot of stuff has been lost. And there is this one reference in Cicero. It's not like you read the ancient Greeks and they talk about pulling out their mechanisms and doing this. it seems to have come almost out of nowhere and disappeared. Chariots of the gods. That's the idea. But they say no. But they're not together.
Or take known. I mean, nobody invented some brand new thing. Put together a lot of known stuff. And
Well, we haven't seen gear wheel. Well, you could say that. Yeah, if it's putting together a vast number of gear wheels when no one has put more than 2 or 3 together before that. Yeah, I still think it's quite an achievement. I think we've got a question here.
What are some of the other theories of what it could be?
Well, I think the calendars are discussed. I particularly don't find that.
What are some of the theories that are maybe mainstream discounted but at least interesting?
I haven't come across any particular odd ones. I mean, there's not much. Well, let's say they weren't got any new theories. Let's try here.
The fact that it hasn't, gears aren't very useful. Your theory that it was this man's toy, this woman's toy, makes a lot of sense because there wasn't a suit and there wasn't a man. So to me, if nobody caught on to that, gears could be useful for telling time.
Mm-hmm.
But what you needed was
Yes.
and that didn't come.
The statement. Yeah. Yes. Yeah, they had other timing things.
Ways of doing it. An hourglass, the mechanism, that complexity, everybody comprehensive. Why would anybody build something like that?
Why? As I say, it's a thing of beauty.
The pages and stuff that had to go into making it, and the recording of for how long, of how much data.
No, actually, that existed. That existed. Yes.
So then this doesn't predict anything new.
No, but to put all that together into this.
Yeah.
Perhaps rather than saying there's no use for it, is it possible that we just not see what the use is?
It's possible, certainly, yes. So.
Oh, I can imagine Richmond's story. I mean, if you have a carrying around bronze statues and other things, the captain and a few well-placed people on the ship are going to have, their ladies or somebody's presenting them with it. The gift of the court or the gift of from the god. I don't know. I can imagine that.
Another question in the back?
Yeah, I can imagine.
Sorry. Yes.
A beautiful.
Is this? Yes, it does. According to this mechanism of rights, when these things, when the two of these dials get together, that'll be when the planets are in the same part of the sky. Yes, that's just what it is do. That's right. Well, then you've got to ask, why do you want to know that? And maybe it's astrology. I mean, they say that is an explanation. Astrology may well be the explanation. But I heard it debunked for some reason which I didn't fully understand. I think there's some question behind you. Yes. Yeah. No, there hasn't. That's the interesting thing, and maybe we'll find them now because now it gets easier and easier to explore the deep ocean. The central parts of the Aegean are deeper than people have explored. You imagine that we find more shipwrecks. Shipwrecks are the most likely place that we'll find them because anything on land, people can see where it's buried, they can dig it up and they can melt it down. But if a ship gets to the bottom of the ocean further than anyone can swim, then it's going to be safe for a long time. The back? The question is, how well crafted are the gears? They are pretty fine, but they're not the design of modern gears. Were they cast or were they cut? I don't think we know. So here, these gears are triangular there, which is Well, you've got to. It's difficult. I mean, corrosion. They're uniform because, yeah, I mean, people have uniform in the sense they're equally spaced. Yes, they are. They're well spaced because people have. These guys have studied every damn tooth on here. I imagine that every tooth probably has a serial number now, and that they've sort of followed these things round, and they found they are kind of evenly spaced out.
I can't even conceive of what kind of a machine shop you would need to create them.
Well, lots of slaves. Yeah, I don't.
It's required.
That's right. There's some
calculations to get the diameters right, the tooth angles right, and
it's probably it's I think what you have to have is that some guy was obsessed to make this, and he had the resources, and he could hire people. He had very high standards, and he was probably crazy, and just really pushed this to get it done. Yes. The question is, did the calendars change around this time? Well, I think that may be, but I think there's only one calendar scale on it. I may be wrong on there, but I've only heard people talk about kind of one calendar scale. It's not like you've got several parallel calendar scales. Yeah. Well, they just changed the naming. They didn't change the positions. Yes. Yeah. Yeah. Well, that's an interesting point because the months are only down there once, I believe. There's only one name for each month, and there are arguments among the scholars as to whether these names are the names used in that part of Greece or that part of Greece or that part of Greece. And they've been trying to use the names of the months to improve the provenance of this. Yes. I can't remember. That's a good question. I don't know exactly what kind of months they were. I don't know how the calendar was set in those days.
I'm just curious, it's kind of an aside, but the Indo-Aryan culture has the same level of understanding about the same time as we did?
I don't know. I don't know enough about either Chinese or in India. Astronomy. Yes. It's in Athens, in the National Archaeological Museum, which is one of the big museums in the center of Athens. And I believe that everything that was taken from the wreck is in that museum. Oh, this one, if you Google, I think if you just Google Antikythera images, in fact, let's just try that. I bet you'll find that, because that one is such a super image. Let's just do.
Yeah.
There we are. That's not the full resolution, but you can probably get there from there. No, it's fine. I don't know if you know, they've just redone Google Images this week, and you now get many, many more. So, yes.
I have a question about when did years of the 1943 here?
When did? Yeah, clocks. There were some very grand clocks built in the I guess, I'd say earlier than that, probably the 16th century, they were getting pretty grand, and you had these sort of astronomical clocks. And I would guess that it was up there. I don't really know. I'm bluffing here.
The other question I had was about, the Greeks back in geometry. Do we know from the written record how they would have calculated geometrically a year of human existence?
Yes, that is not that difficult, I think. And you've got to be. I mean, for example, that little equation I showed you, where you had 6 gears combined to produce this thing with a precision of 1 part in 100,000. I suspect that's not too hard to do. But I never actually tried it. I mean, it's like us throwing out a random number at you and asking you to come up with gears to reproduce that ratio. I don't know how hard that is. Do you feel?
Well, maybe you're asking how hard it is to make the year.
No,
How to calculate the fraction of a degree, 43 billion, 60, whatever they thought of that.
well, I think the way you might make a gear like that, I have a theory about how you might make a gear with teeth like that. I mean, one is you start off by making a gear with perhaps 16 teeth, which you can probably do, made of a hard metal. Then you know roughly how big your 243 tooth gear is going to be, and you make a disc. And then you put them next to each other, and you kind of rotate them round against each other, so that the small gear makes little teeth marks. And you count how many teeth marks you've got. And presumably you've got too many, so you grind that thing down a little bit. And then you do it again. You grind it down a little bit more until you end up with exactly 243 little teeth marks on the thing. That's the way I thought we could probably get going on doing that. Yes?
My mother, the first time that
And she wasn't a second life? Yeah. Mm-hmm. Yes. Yeah. There is a book, by the way, by Jo Marchant. Jo Marchant is the woman who was narrating that clip that had Michael Wright in it. She's written a book that came out about 2 years ago. I'm sure you can find that on Amazon if you just look up Antikythera on Amazon. And that's quite good. There's quite a lot of stories about the personalities. There's some interesting personality clashes going on between the various different groups here. But I haven't met any of them, so I don't really want to comment on those. They're all Brits. Yes?
I saw something on Google that somebody, it's not published yet, it could be 100-200 years old based on, did you see this?
No, I didn't.
Based on one of the predictors for the game was called NAA, NA, or something.
Yeah.
And that was by the time they're saying, by the time they're dating the next
Mm-hmm.
that was already under Roman rule.
I see.
And they wouldn't have given the Greek name for it.
Oh.
Well, if you
Okay. I haven't seen that. Do you know where that was published? Nature?
it hasn't been published, but the article was on, I think, the Guardian.
Okay. I'll look that up.
I don't know if that's a lot of the rest of the paper.
I read it every day. My 2 papers are New York Times and The Guardian. Okay. It looks like people have machined themselves out now. So. Okay. Thank you.